amphibious assault is the most complex of all military operations. Each assault is unique and demands a different combination of ships, aircraft, and landing forces. It must be planned to anticipate every aspect of the operation, from the initial assault to the follow-on logistic support of our combat forces. No less important than the assault itself is a well-organized multi-force logistics operation. Once the beach is secure, the combat troops will need fuel, rations, ammunition, medical supplies, and other vital logistic support that allows them to continue as an effective fighting force. To assist them on their path to victory, these supplies must arrive where they are needed and when they are needed. When conducted by each individual service, this is called logistics over the shore, or LOTS. When these operations are carried out by more than one service, such as the Navy and Army working together under one joint force commander, the operation is called Joint Logistics Over the Shore, or JLOTS. When conducting a JLOTS operation, the men and women of a multi-service force can maintain a continuous flow of supplies over a bare beach or through an inadequate or damaged port. JLOTS can also be used for humanitarian assistance, disaster relief, or peacekeeping operations.
The LCC is already established on the beach.
JLOTS, with joint sea lift or airlift components, requires careful planning and coordination of all forces involved: the Navy, Army, Marine Corps, and Air Force. Once an amphibious operation is complete, the Navy and Marine Corps will normally commence a LOTS operation. As Army forces arrive and merge with Navy and Marine Corps forces, the Joint Force Commander will direct a transition from a LOTS operation to a JLOTS operation. Early in the planning stage, the Joint Force Commander designates a JLOTS commander to assume responsibilities for the joint logistics operation. The JLOTS commander will oversee every aspect of the operation, from initial planning to delivery of vehicles, containers, and supplies to inland marshaling yards. The JLOTS staff will be composed of representatives from all of the participating services. Additionally, the JLOTS commander will coordinate with the Joint Reception, Staging, Onward Movement, and Integration commander to ensure seamless handover of material with full in-transit visibility. To define the JLOTS process, the JLOTS commander must fully understand the entire mission. To select the best site for the JLOTS operation, they must assess the enemy situation, collect intelligence, and analyze terrain. This requires checking weather conditions, factoring in the beach gradient, tides, ocean bottom, and many other critical factors. After considering alternative courses of action, the JLOTS commander selects the best course of action and obtains approval from the Joint Force Commander, then publishes an operational plan that is disseminated to all participating forces. Once the joint planning phase is over, the individual services prepare for their respective roles in the operation. Strategic Sea Lift shoulders the many burdens for delivering equipment and supplies to the fighting forces ashore. Orders go out to the Military Sea Lift Command through the United States Transportation Command for Strategic Sea Lift ships capable of conducting port operations and JLOTS operations from Anchorage. It is essential that all cargo be loaded according to how it will be discharged. When equipment is unloaded, containers, vehicles, ammunition, fuel, and other supplies must be made available in the correct order as determined by the mission requirements. To create the most effective lighterage routing, when ships arrive at their predetermined sites, they are assigned anchorages according to ship's characteristics, lighterage routing schemes, cargo types, and security needs. Once a ship arrives on station, a ship's arrival conference is conducted with the ship's key personnel, an MSC representative, JLOTS commander representative, and other vital personnel. Their purpose is to clarify specific working relationships and to determine responsibility for various routine operational matters such as refueling times, shift changes, and cargo offload sequence. Both the Army and the Navy have their own lighterage and shoreside discharge systems. Lighterage refers to small craft designed to transport cargo or personnel from ships to shore. Lighterage includes amphibians, landing craft, and causeways. Shoreside discharge is achieved with using floating causeways, elevated causeways, piers, or over bare beaches. Both elevated and floating causeways are constructed to ensure the safe delivery of cargo from ships to the beach without entering the surf zone. Bare beach operations require particular care to protect cargo from wetness and weather damage and to avoid broaching due to beach conditions or getting vehicles stuck due to lack of traction. Both Navy and Army forces can unload lighterage from strategic sealift ships and deliver rolling stock, tracked vehicles, and containers to the various discharge sites ashore. The Army and Navy use similar components to construct causeway systems that support offshore offload of roll-on, roll-off, and lift-on, lift-off cargo. Naval beach groups or Army sustainment brigades will prepare the beach to support floating causeway or bare beach operations. The Army has several types of lighterage, which includes the Logistics Support Vessel, or LSV, LCU 2000, LCM-8, and the Modular Causeway System, or MCS. The LSV is the Army's largest powered watercraft. They are 273 feet long and designed to carry up to 2,000 tons of cargo from strategic sealift ships to shore during JLOTS operations. Additionally, LSVs are critical force projection enablers, primarily used in intra-theater contingency operations. The LSV can self-deploy from anywhere in the world and provides worldwide transport of general and vehicular cargo in support of JLOTS operations. The Army's LCU 2000 is 175 feet long and can carry up to 350 tons of cargo. It can transport rolling and tracked vehicles, containers, and general cargo from ship to shore, as well as to areas that cannot be reached by ocean-going vessels. It can self-deploy or be transported aboard a larger vessel. The LCM-8 is 74 feet long and can carry up to 65 tons. It is designed for LOTS operation of troops, wheeled and tracked vehicles, or general cargo. Both the Army and Navy have LCM-8s. The LCM-8 is ideally suited for inland waterways, limited coastal logistics support, and loading or unloading of merchant shipping in undeveloped ports. It can be transported as deck cargo or inside a well deck. The Army's Modular Causeway System, or MCS, is used to support ship-to-shore movement of cargo during a JLOTS operation. These systems can be transported in 40-foot by 8-foot by 9-foot International Organization for Standardization, or ISO, container-sized packages called ISOPACs. There are 4 MCS configurations. The Roll-On, Roll-Off Discharge Facility, or RRDF, provides an interface platform between roll-on, roll-off ships and Army lighterage. The Army Trident Pier provides a floating causeway with pierhead at beaches for cargo discharge outside the surf zone. The Army Warping Tug is self-propelled and outfitted with a deck winch and A-frame. The warping tug is used to place and retrieve Trident Pier anchors and assemble, disassemble, maneuver, install, and retrieve the RRDF and Trident Pier. The warping tug also conducts salvage. The Causeway Ferry is used to transport containers and rolling stock from strategic sealift ships through the surf zone and onto the beach. The Navy lighterage includes the Improved Navy Lighterage System, or INLS. It is designed to support ship-to-shore movement of cargo during LOTS, JLOTS, and humanitarian operations. There are 5 INLS configurations. The Navy warping tug is 84 feet long and 24 feet wide and is propelled by 2 diesel-powered water jets. It is used to deploy anchors for the floating causeway, maneuver the RRDF and floating causeway, and conduct salvage operations. The Navy Causeway Ferry Power Module, CFPM, is 80 feet long and 24 feet wide and is used as the propulsion module for the Causeway Ferry and supports assembly and maneuvering of the floating causeway and RRDF. The Navy Causeway Ferry, CIA, is 240 feet long and 24 feet wide and can carry approximately 270 tons of cargo. It consists of 1 Causeway Ferry Power Module, 1 non-powered intermediate module, and 1 beach module. The Causeway Ferry receives cargo at the ship's side or while moored to the RRDF and transports the cargo directly to the beach, to a floating causeway, or to the elevated causeway. The Navy Roll-On, Roll-Off Discharge Facility, or RRDF, consists of 9 non-powered modules connected together and provides an interface platform between a roll-on, roll-off ship and lighterage. The Navy Floating Causeway consists of 19 non-powered modules and provides an anchored floating pier for cargo discharge outside the surf zone and onto the beach. The Navy Elevated Causeway, or LCAS, is assembled in a cantilevered fashion by driving piles and securing them without contending with the surf zone. LCAS has 2 cranes and 2 turntables to facilitate the offloading of cargo from lighterage moored alongside. The LCAS floating causeway and roll-on, roll-off discharge facility must be strong enough to withstand potential damage from foul weather or heavy surf. The Navy's LCU 1600 transports wheeled and tracked vehicles and general cargo from ship to shore. Roll-on, roll-off missions are accomplished using the vessel's bow and stern ramps. It is valuable in LOTS operations and intra-theater transport using harbor and inland waterways. The LCU 1600 is not capable of self-deployment over open oceans. It is deployed aboard Navy vessels, barges, and other larger vessels. The MPF utility boat is a 40-foot aluminum landing craft used to transport up to 30 personnel for shift changes. It is also used for medical evacuations and security patrols. The lighter amphibious resupply cargo, or LARC-5, is an amphibious vehicle that is 35 feet long and 10 feet wide and can carry up to 5 tons of cargo on land and 2 tons of water, or up to 20 personnel. The LARC-5 is used by the Navy Beachmaster units for lifeguard detail during surfside operations, transferring material and personnel through the surf zone, and towing stranded vehicles clear of landing craft. The LARC-5 also has firefighting and dewatering capability. The Combat Rubber Raiding Craft is an 8-person inflatable craft designed to support JLOTS operations. It can be launched from the floating causeway, RRDF, or ABLATS platforms using a J-bar davit. The craft is used to pass mooring lines, deploy mobile repair teams, and to provide transportation from shore to ship and ship to shore. The Army Trident Pier and Navy Floating Causeway are both configured with 3 pierheads for simultaneous discharge of cargo from lighters such as the Causeway Ferry, LSV, LCU 2000, LCU 1600, and LCM-8s. The floating causeway and Trident Pier also provide a docking pier for lighters undergoing maintenance and for cruise ship changes. The Navy's Amphibious Bulk Liquid Transfer System, or ABLATS, provides the initial liquid products ashore from maritime prepositioned ships to a beach interface unit. ABLATS is used to supply fuel and potable water to ground forces until the offshore petroleum discharge system can be installed. ABLATS is a self-contained system capable of deploying 10,000 feet of 6-inch fuel or 10,000 feet of 4-inch water hose lines from a designated ship to the beach interface unit for up to 30 days. The system can be offloaded, assembled, deployed, and operational within 8 to 10 hours after ship anchorage and has a crew of 15 Navy personnel. When fuel will be required for longer periods of time, the USNS Wheeler, a fuel terminal capable of delivering fuel from 8 miles offshore, provides the key elements in an offshore petroleum discharge system, or OPDS. Fuel is pumped through a flexible pipe to the beach termination unit for further transfer to an onshore fuel farm. When functioning at full capacity, the OPDS can deliver 1.7 million gallons of petroleum products every 20-hour day. The system can be installed within 48 hours. The JLOTS commander must ensure that unloading equipment such as rough terrain container handlers or RATCH, cranes, fork trucks, and tractor trailers are organized for distribution of vital cargo quickly and at the right time. Ships are matched with the type of cargo being offloaded. Roll-on, roll-off ships have the advantage of fast turnaround when equipment can be driven on and off. Therefore, they are best for transporting tracked or wheeled combat equipment. With its capacity to transport the Navy LCAS system, the CB ship is best able to transport outsized military cargo such as INLS craft, LCMs, LCU 1600s, LARCs, and other heavy equipment. The Joint Lighterage Control Center, or JLCC, is the key coordinating center for lighterage usage plans. The JLCC provides overall lighterage management and guidance throughout the JLOTS operation. This includes monitoring ship-to-shore movement of lighters, assignment of lighters, dispute resolution, establishing lighter anchorage sites, coordinating waterborne medical evacuations, managing safe haven, and controlling lighterage entry and exit from the operational area. The JLCC is normally located ashore, where they can be positioned to afford the best visibility of the lighter operating area. The Ship Lighterage Control Point, or SLCP, is stationed on each ship that keeps track of and controls the movement of cargo and the lighters assigned to it by the Joint Lighterage Control Center. The Beach Lighterage Control Point, or BLCP, is responsible for directing lighters to the correct beach transfer site for offloading cargo. The JLCC will direct the lighters to contact the appropriate BLCP for assignment to a beach transfer facility or bare beach site. The BLCP should obtain information from the SLCP or from the lighter itself as to the quantity, type, and status of its inbound cargo. The Beach Control Group is responsible for the movement of cargo from the beach lighterage control points to the marshalling yards. Regardless of the lighterage used, movement of cargo is weather dependent, and as the sea gets rougher, throughput will be affected. Over the centuries, it has often been said by military leaders that the key to success on the battlefield is to deliver vital supplies to their fighting forces where and when needed. This requires a tremendous amount of planning and coordination, and the ability of all participating services to work together as a smoothly functioning team. From preparing the beach or pier, to coordinating the arrival of prepositioned ships, to organizing the efficient and timely transfer of cargo from ship to shore, and marshaling it for movement inland. The objective of JLOTS is to maintain that steady supply of logistics support to fighting forces ashore and make a vital contribution to victory.